Welcome to the lecture on Chapter 13, Business Intelligence and Data Warehouses. So we'll be using data mining as part of our business intelligence. And data mining's a methodology for searching data for patterns. And the goal is to turn a business problem into a data problem. And with that, we can apply our data analytic methods to the data problem. There's some potential problems with doing this. Selective observation, illusory correlations. In other words, we think we see something, but it's actually not there. Not properly selecting our sample. The data we have is not relevant to our study objectives. So care has to be taken in this type of business research, especially because full control and repeatability is not possible in business analytics and business intelligence. So the methods for sampling the data we use in business intelligence and we store in data warehouses, the methods for sampling or selecting that data fall into two categories. Probability sampling, where the data is selected randomly, and this is required for calculating mathematically precise probabilities, confidence levels, and error rates. The other is non-probability sampling, and that's where the data is selected in a purposeful manner related to the objective, but this, in fact, precludes precise confidence levels and error rates. So we'll talk about business intelligence, which comprises several fields, including OLAP, and that's where we have known associations in our data store or data warehouse. In other words, known numbers and known dimensions or ways to categorize our numbers, like categorizing sales by product or categorizing sales by season or categorizing sales by geographic region. OLAP sums or pre-aggregates these numbers across these dimensions so they don't have to be continually calculated and become a drain on our computer resources. The second field in data analytics is going to be data mining. And this is where we search for associations between the data, but we don't know them in advance like we do with OLAP. With OLAP, we know we want to get our sales by geographic region or sales by season and so on. Not so with data mining. There's many different techniques for data mining, and we'll be discussing the major ones shortly when we go through our example. Text analytics is another area of data analysis, and that's where we use natural language processing to discover meaning in large sets of data. So we'll go through a machine learning demo, and this is the process of automatically analyzing data from databases in this particular case to find a useful pattern. We can classify things. That might be the pattern. We can make predictions on future values using regression. So prediction is based on past history. We can predict if a credit card applicant poses a good risk based on some attributes that are inputs like income, job type, and age. And then we've got an outcome, which is there a good or a bad credit risk based on the values of those input attributes. Likewise, we can predict if a pattern of phone calling card usage is likely to be fraudulent. So some examples of prediction mechanisms are classification, and that's given a new item whose class is unknown, predict to which class it belongs. And we're going to be doing that demo here in just a minute. And then regression formula, and that's given a set of mappings for an unknown function, predict the function result for a new parameter value. Okay, let's take a look at our issue here. Here we go. So the demo we're going to be looking at in terms of business intelligence and machine learning is to apply or show how to apply three of the very prominent classical machine learning algorithms: naive Bayes, k-nearest neighbors, and support vector machines. And we'll be doing this on a Stack Exchange data set. For those of you who aren't aware of Stack Exchange, it's a question and answer forum, and it's got 190 plus different forums there. The smallest is the movie forum, and so we'll be using that because it's small enough that you can actually do this type of analysis on a small PC. The first thing we do is the prep work. So I'll open that directory. And you can download all of the data from the Stack Exchange database in XML format. And so I have done that, and I've got the various things like the tags. In other words, you post a question and then you give it relevant tags for the topics or categories you think are most applicable. And then also the posts themselves, the history of the person who made the post, any comments on it, so the votes on it. So I download the entire database, and then what I'll do is I have a program, questions.make, and in that one I create the actual database from the XML files. So here's the Python code that shows making the database. And so I've made my database, and it's called SO Stack Overflow -dump, because this was a dump of their database. And I've included the relevant parts I'm interested in my own SQLite database, sodump.db. And from there, I can then run a program to create a model. So I'll read the data that's in my database, and I will create a model. Now, this takes a long time to run, so we won't actually be running it here. And I import various libraries I'm going to use. scikit-learn is one that has a lot of machine learning in Python. And I read through my database, and then from that I create a list of labels, in other words, categories for each question that was asked. And then I have, along with that, a separate list of associated questions, and of course I have a link between them. Then I will make a model based on one of three things. I've chosen the support vector machines here. I tried naive Bayes and k-nearest neighbors, but they, in this particular example, weren't quite as good as the linear support vector machine. So again, these are all libraries that are available to Python programmers. You're not expected to know how to do Python programming. I just wanted to show you how it's done. And the programmer has the option of picking different models and then testing them to see which one gives the most accurate information, and then going with that. Then, once we've got our X and Y data, in other words, X is going to be our questions that we want to categorize, and Y is the categories, then we create a model for doing that. And that's a mathematical model, and you might think of it as similar to like a regression type model, but it obviously in this case is for classifying. And then we save it, and in Python, the format for saving these type of data models that's very effective is the pickle format. So we use that one. And then once I've created, and you can see this is the model here, so-questions.pickle. It's 2 gigabytes. So even on a relatively small database of 236 megabytes, we get a large data model that helps us then classify the input that we expect in. In this case, we're going to be classifying a question that comes in and give it relevant categories that it might be pertaining to. So we can actually run that model, and here's an example of a program that lets us run that model. And basically we're going to read in our model, and then we load it in the parlance of pickle, and then we've got it in our model. Then we're going to get the classifier out, that's the part that lets us do the classification. A vectorizer, which prepares a question for input into our model. And then we create the model itself, and then we're ready to start asking questions and feed it in. So let's take a look at how this actually runs. Minimize this and then come up here. So you can see I've put in my Python program, questions.run. The model is the so-questions.pickle, and I'll type in a question. Who are Roy and Deckard? So this is a question it hasn't seen before, but based on its analysis of the 230 megabytes of questions, data, and associated labels, it predicts that these particular nouns, Roy and Deckard, are related to a movie called Blade Runner, and it's in a category of analysis as well. So the two categories, the movie Blade Runner, and what was done with the question is analyze the plot. So I'm going to exit here, and then we'll go into the next part, which is the artificial intelligence part. So currently we have a machine learning model called questions.pickle. It does one very simple thing for us. It'll categorize a question about a movie into a proper categories. And with that category, we then have a keyword or key for going out and getting other related information about that. So I can go out to IMDb and get information about Blade Runner. So I'll go ahead and fire this up, and it'll take a minute to load. So those classification rules, in other words, we have this question coming in and we want to classify it, they help assign new objects that come in other words, new questions, to categories or classes that we might want to use then to look up because we've got a lot of information about those classes. Classification rules use a variety of data. As we've seen here, I just downloaded the information from Stack Exchange Movie Forum. The rules are not necessarily exact, so there's going to be some potential misclassifications, and we can often show those rules in a very graphic, simple to understand format. So this also points out there's actually two types of machine learning. Supervised machine learning is using data that's already been tagged or labeled to perform our classification. And of course, that's what we're doing here. So we typically will divide this data into a training data set where we actually prepare our model. And then we likewise have a testing set that we can test the accuracy of our model. And then we could also test and then compare the accuracy of, say, our model using support vector machines to a model created using naive Bayes or a model created using k-nearest neighbors. So that's supervised learning. You have data that's already been tagged. Unsupervised learning, on the other hand, does not require the data, the input data, to have an outcome already labeled. So in our case, the outcome is the classification. So our goal is to predict some outcome based on the value of features in our input. Features are whatever inputs we provide into our model. Typically it's going to be attributes or characteristics of the data records. And our data are sets of records that are combinations of these values for these attributes and also an associated outcome. So that is a natural for storing in databases. There's a couple of categories of features. You can have a simple yes or no, it can be a number, or it can be a choice from a discrete set of options. And as we discussed, there's 4 prominent classic modeling tools for prediction. Bayesian statistics, and that's suited to yes or no features. K-nearest neighbors, and that's suited to numeric features or choice from a discrete set. Support vector machines, which is suited to numeric features or choice from a discrete set. And then a decision tree, and that's a mix of numeric and categorical data. So let's take a look now that we've got our program loaded, our artificial intelligence program loaded with our model, soquestions.pickle. Now let's ask the same question. So what we do with the artificial intelligence is we have a set of machine learning algorithms that we can use to do various things like classify or perform a regression or some other machine learning activity, and we can then combine them to get information and then go out and use those new categories as keywords to get extended information about our particular topic. So now let's look at this same question: who are Roy and Deckard? So we break it down into the parts of speech and name the parts of speech. Prepare a select statement, which you can see here, that will go into our SQLite database and find some information relevant to this topic there. So, for example, in the analysis we see down here, Deckard goes to retire an android, and we find out he's one of the key things is Roy is perceived to be more human. The robot Roy is perceived to be more human than the person going out to retire him, Deckard. And then we can also get a series of quotes from the movie, and it gives us a short plot synopsis. A Blade Runner must try and pursue to terminate 4 replicants who stole a ship in space. And then some of the quotes we see here, like Terrell talking about why he can't change Roy, because Roy wants to be changed. They have a time mechanism where they die after 4 years. And so he goes through the whole reason why that's not possible. So we get a little more information from our model when we extend it with other stored information. So kind of a recap, there's 2 phases in machine learning. The first is to create the model, and this is the learning phase. The second is to apply the model to items of interest, and this is the prediction phase. So once we've got our model created, then we go into phase 2, which I just demonstrated, where we apply it to new input, new questions that come in, and then we can make categories for those. Classification that we did here is a category of supervised learning. It assigns a correct class or tag or label to an input item, and supervised with a training set of items with known classes, labels, or tags. And it's an important aspect of problem solving to find the knowledge domain or class and then find associated problem domains and their solutions. So this is another way we can actually use it. You have a question come in, and then you find particular knowledge domains, and then you ask other questions, you get responses, you analyze the responses until you can start narrowing down, and then you start getting some information about the problem that they asked about based on the key words. But you've started at a higher level with classifications. So, tags, that's the name that's commonly given, and in the machine learning libraries, that's what it's called. A tag is a synonym for a category, a class, or a topic. And again, the idea is you use a classifier to tell you what topics or categories the question is related to. Then you can find related materials relevant to your question, even without any word matches between your question and the topic. Okay. Right, let's go on with our lecture. So, business intelligence is a set of tools that allows a business to transform a business problem into a data problem. And with that, we can then apply machine learning mechanisms to the data problem and give some useful feedback about the particular problem to the business manager. And so there's several parts. We have to, one, get our data into a data mart. So we have a variety of external data that we see here and operational data, and we use a functionality known as extraction, transformation, and loading to put that into a data mart. So what I did is I just download, you're not given direct access to their databases on Stack Exchange, but they will give you their nightly dump in the format of XML. So I got that data, I did an extraction, transformation, and loading of that into a data mart, and I just happened to put the data mart in the SQLite 3 database engine. And then from there, you start doing querying and alerting. And so we did that with data analytics. And then a next step might have been data visualization. So then with visualization, we can get even better information. And some of the types of output would be a dashboard. So that's going to show key business performance indicators. You've also got data analysis and reporting tools. Many of the popular data analysis packages have those. Python comes with a set of libraries that make use of a graphical package called matplotlib to do this. You're also going to need a data warehouse. That's where you're going to store this information that you're collecting. Obviously, we just did a very simple collection. But we could have gone out to a variety of other sources like Wikipedia and so on and started downloading a lot of information about movies into our movie data warehouse. And then we have the OLAP tools and data visualization, and that's for actually presenting this data to our customers. So again, we're going to be using a set of concepts and techniques that are well known in machine learning. They've been published and they're used worldwide in a variety of different formats, Excel, Python, R, and so on. And those will help us provide insights into problems or questions to management. So data visualization is a powerful tool available to the data analyst for mining our collections. Modeling and visualization are used by data analysts for both communication and for analysis. They've historically been used in science and engineering for millennia. The design visualizations by the Roman Marcus Vitruvius are still available today. James of St. George was known as an ingeniator, the term of art that led into the term engineer. And then Mason, which is, of course, the modern term would be mason. Leonardo, Gaspard Monge is another one. The rise of visualization really started to take off during the Industrial Revolution because it increased the complexity of the design of the systems we were working on. So there was increased pressure on visualization to keep pace with methods and tools to communicate, analyze, and for record keeping. Gaspard Monge's descriptive geometry was a state military secret for France from the time of the Napoleonic Wars up until World War I. Visual analysis became an integral part of ensuring a correct and optimal functionality. And it was used to communicate to others and also to create historical records to monitor change. Data analytics today presents us with two problems. how do we make sense of the data, and how do we communicate the results of any analysis on the data. And visualization is a solution by leveraging our perceptual thinking as well as our analytic thinking. So today, you see pie charts and bar charts. Today, the computers revolutionized visualization. Computer graphics is now a principal analysis tool. Additionally, graphics is now the principal presentation tool. Visualization activates spatial reasoning ability, and that's an assist to our verbal description and our verbal reasoning ability. By using different parts of the brain, more memory is going to be available to us to aid in understanding the problem. It engages our perceptual as well as our cognitive systems in the brain. And the perceptual system operates in parallel while the cognitive operates serially. So visualizations often explain the data better so we can make sense of the relationships or patterns. It helps us see hidden relationships. It helps us to identify trends. And the visual reasoning built around our eyes excel at scanning and recognizing patterns. Graphics leverage this in multiple ways. They can assist comparisons by varying the length, shape, or orientation or representation. Animation can represent change over time. Color can be used for grouping and to show distinctions.